Good day, students. Right, in this video, I will be doing solutions to question 1, parts A and B of yesterday's Add Maths Paper 2 exam. Right, the first one, determine the other linear factors of the polynomial 3x cubed plus 8x squared minus 20x minus 16, given that x minus 2 is a factor. Right, so these are steps that I've highlighted here. We're just going to divide the polynomial and then factorize the quadratic that we get, right? So what we're going to do here, x minus 2 into this polynomial. You'll get this here as the quotient, and of course you have to end up with a remainder of 0 because x minus 2 is a factor. So yeah, our quadratic, we will factorize that further, and that would give us the two other linear factors that they want us to answer. Right, it's the factorized version of the quadratic. Okay, so keep in mind that x minus 2 and these two, when multiplied together, give us back the polynomial. We'll need to use that just now. Right, so when we need to simplify what's given here, we have the same polynomial at the top. I will replace it with the three linear factors. And the denominator, x squared minus 4, we can factorize that. That's the difference of two squares. Square root of x squared is x. Square root of 4 is 2. So that will change into x minus 2x plus 2. Right, and it's multiplied throughout all of the terms. So we can cross off like this x minus 2 with x minus 2. Right, the tool that I'm using right now is a little limited, so I don't have annotations. So I'm just going to highlight what we are going to cross off. This x plus 2 here with this x plus 2. And then the denominator x plus 4, cross that off with this x plus 4. That leaves 3x plus 2 as the answer. I know it looks like a negative, but Google Docs is doing some craziness sometimes where sometimes my equal looks like a negative. That's the answer, 3x plus 2. As simple as it can be. Right, question B, the equation kx squared plus x minus 15 equals 10 has roots alpha and beta, where k is an element of w. W meaning whole numbers, and there's a little issue with the answer for the second part. When we look at the two answers we'll get, it's neither of them are whole numbers. So this is the error that people have been speaking about. The w or whole numbers should be either, well, actually I think it should ideally be r for real numbers, which is any kind of numbers, because I really wasn't sure if the numbers we were getting were rational, or if it was just a rounded off answer that I'm getting with my calculator. That's the thing. Right, so it's should be R. Anyway, determine expressions for alpha plus beta and alpha beta. We need to recall Vieta's root theorem, which states the sum of the roots is the same as negative b over a, and the product of the roots is c over a. Right, now the given expression is not really in the form of a quadratic. We have to move the 10 across, make it negative 10, and then simplify this. Right, so now it's in the form of a quadratic where we have ax squared plus bx plus c, that form. Right, the c value is negative 25. Right, the b value is 1, and the a value is k. Okay, the sum would be negative b over a, which is negative 1 over k. There. Okay, and the product c over a is negative 25 over k. Right, we'll need to use those two in the next question. Right, given that alpha squared plus beta squared is 61 over 4, use the expressions in B part 1 to determine the value of k. Right, so this question has, it actually turned out to be really long, so I think the number of marks should have been different as well. I don't know, I'm estimating around 8 marks maybe. Right, and of course with sum and product, you would have probably thought about these here. Right, so if you have alpha and beta as parts of two fractions, you would have to like simplify them into a single fraction, or here you could use your laws of indices to simplify this further. This is the one we actually need. A common mistake is to express this as alpha plus beta in brackets squared, but we need to include the minus 2 alpha beta after it as well. Right, so this here is what we replace alpha squared plus beta squared with. Now, alpha plus beta, that's the sum, which we found in the previous question, sum of the roots, and this alpha beta, product of the roots. If you're squaring a fraction, you are squaring both numerator and denominator. So this will expand into 1 over k squared. Negative 2 by negative 25 is positive 50, so 50 over k. And I'll combine these two terms on the left into a single fraction. I'm going to make that 1 plus 50k over k squared, and then I'll cross multiply from here. Right, so numerator of one side by denominator, the other side gives us this. I'm going to expand this. That gives us 4 by 1 is 4, 4 by 50k is 200k. I'll move this over to the right side, or to the side with the 61k squared. Make them both negative. Right, so now it's in the form of a quadratic. You know, you could actually solve for k now is to either use factorizing or the quadratic formula, and for this one I don't think it could have been factorized. Those numbers are just too weird. So I used the quadratic formula and I came up with two solutions. Right, and you're seeing that neither of them are whole numbers, and they had originally told us k is an element of w, meaning whole numbers. Right, now what I have here, these are just rounded off. This one is rounded off to 1 decimal place, this one is to 2 decimal places, right? And we have to decide which one is the solution. We only have one solution, and it's going to be this because, right, the discriminant of the, well, if you're using 3.3, right? 3.3 here in this graph, that would be our A value. We'll have 1 is B and negative 25 is C. If you find the discriminant, right, using the 3.3 as the C value, you get a positive number, which indicates this graph has two roots. Whereas if you use this here as the K value, or the A value, right, that's our A, 1 is B, and negative 25 is the C value, right? So yeah, it's the A value. I feel like I may have said something in front here. The A value is 3.3, right? So here our discriminant turns out to be a negative number, which means this graph has no roots. So you can't have sum and product and stuff of roots if you have no roots. So this graph here is the one with the two roots that would have the sum and product being certain values. I have a graph here. Let's take a look at this graph, right? So this is the graph of the two equations they gave us. I use a graphing calculator. So you're seeing the green graph. That's the one with the negative 0.02 as the A value or the K value, and the other one with 3.3 rather. And you have these two roots. So it's not part of the question to figure out what the roots are, but I'm going to just verify that these two roots, or the product and the sum of these two roots, are what we are given here. The product, and well, let's do the sum first. So using the equation, the sum should be negative b over a. So negative 1 over 3.3. That gives us negative 0.3. And using the roots that we just saw in the graph, the sum should be, well, the sum is negative 0.3. The product now should be c over a. So from the graph, c is negative 25, and a is, well, not from the graph, from the equation, is 3.3. Dividing that gives us something around negative 7.58. And using the actual roots that we saw in the graph just now, the product turns out to be negative 7.54, and these are just rounded off values as well. I don't think the roots were actually even rational numbers, because I kept zooming in and the numbers just had more and more decimal places. So yeah, but yeah, they're close enough. Right, so I think the 3.3 is the answer that they wanted. Yeah, so that's our only acceptable solution. And yeah, so I will leave you all there with that for now, and I'll try to upload some more solutions when and if I get time. Thank you all for watching. Take care, everybody. Bye for now.